Hello, good morning, everyone. This is day three for the Data Science Bootcamp. In today's lecture, we will be covering NumPy and we'll be understanding like why we should use NumPy and how efficient it is. Okay, let's get started. Okay, can you see my screen? Devesh, can you see my screen? Screen is visible, right?
Yes, it's visible.
Okay. Any idea on NumPy, like what it is? Did you get a chance to look at the video that I've shared?
In the video, it's a library of a Python where we can
Mm.
where we have what is used for the clean the data, like
Yeah, clean the data, manipulate the data. We use
man,
Python for that. Okay.
import the data from the files.
No, got it. Got it. So see, I'll quickly go through it. So that is not very important. Why how if Python is, I mean, to understand like NumPy is extremely fast. The reason being that it uses C in the backend. There are a lot of things that happens on the backend. That's the reason NumPy is very fast. Uh, when you iterate through a list, let's say in Python, you can't do it on a large number of data sets. At the end of the day, it's scalability that matters. Like when you and I code on system, it's either like 100 items, 10,000 items at max. That's what we can do. But when it is on a company level, let's say it's Facebook, let's say any company, it's Dream 11 or ShareShare, they have data at billions, at petabytes. That is the scale. That is not handleable the way Python handles it in their core. So NumPy uses a lot of things. One of them being is vectorization. Are you familiar with what vectorization is?
So, like showing in a graph way, the data.
Yeah, sort of. So when let's say if you iterate through a list, it will be one element after one element. So it is kind of like post to a stack and then pop to a stack. But in vectorization, a lot of elements runs on parallel. So that's how it is fast. So the reason we use NumPy because it is very efficient, it is fast, it is back on the back end, it uses C languages, which is very close to the hardware. Whereas Python is something it's sit on the top of a C language interpreter. So it is way slower. So what we'll do today we'll understand NumPy. Okay, I'll quickly open my Jupyter notebook. Can you see my screen?
Yes, sir.
Okay, it's Jupyter notebook, right? Okay, we will start with the comparison of NumPy and Python. Okay, how it is uh, different in NumPy, how it is different in Python. Okay, give me some time. I will just do it. Hmm. Can you see my screen?
Yes, sir.
Okay, okay. So Devesh, if you look at the screen, so we have one list, list one and list two. Both have three elements. We'll run zip. So what zip does, zip will create a tuple of two elements. It's more like stitching two elements, like if you understand. Like when you zip it, two arrays get joined and it creates a tuple like this. So let's say 1 of 6, 2, 7, 4, 8. This is how a zip is created. Now next what we are going to do, this is we have an element. This is an operation that we perform. Now we will do similar operation using Python list. Okay, at first what will import NumPy. This is how you import NumPy. Import NumPy as empty. Then import time. This is how you can define a constant in Python. The reason being, if you can see this underscore, it may looks like it's invalid, but after putting underscore, it is very readable. So the amount, number of the size of this element is it's 1 million. Okay. So if you go ahead, so we are creating a list L1 of size 1 million. So that is 10 lakh. Then list 2 of 10 lakh. Then we have put a start time. Then what we are doing, we are running a list comprehension and we are creating a zip like this for 1 million elements. Now, if you see what we'll do, we'll run it and then we're printing first 10 elements because printing 1 million elements would be very slower and it would also like put a lot of load on the memory and the notebook may crash. So we'll be only printing the first 10 elements. Okay, this is how you do. This is we are importing time. This is the start time. So at this point in time, we know like at what point it started. This is the end time after the execution. This is the end time. And what we are doing end minus start. So we get like how much time has been spent. Okay, I'll just quickly run it. It may take a second or two. Let's see. Okay, you're seeing we are doing a zip. We are doing an add on the zip. You're understanding? Are you able to visualize? Do you want me to go through this code?
No, no, sir.
You get it, right? So it is
Yes.
just doing an addition of two lists that has come. 0 plus 0 is 0, 1 plus 1 is 1, 2 plus 2 is 4, 3 plus 3 is 6. You get it, right? Okay. Now, if you see the time consumed is 1.4 seconds, which is a lot. 1 second is a lot for an execution. We will do similar program using NumPy. Okay. Same imported NumPy, imported time. In this previous one, NumPy was not needed. It was just there. Size is set up. Now, this is how you create an NumPy array. np.array and the first argument is the list that you want to pass. You can pass a 2D list, 3D list, any list. Okay, we are passing a 1D list with a size of 1 million. So there are 1 million elements in this list. Similarly, start time and end time. And as you can see, NumPy it is different. You don't have to run list comprehension. It uses vectorization. So you can just simply do a plus. Yeah, there are a lot of mathematical operations available on NumPy. NumPy actually stands for numerical Python. So there are a lot of numerical operations that are available in NumPy. So if you see L1 plus L2, then end time, then again we'll do this the same. I'll run it. Okay. As you can see, it took a longer than I expected. Similar array elements, okay. The execution time is 0.5 seconds and this is 1.5. It is three times faster. It is three times faster. It is very, very, very fast. If you see in terms of computer science, this is very fast. Okay, 0.48 second for now. So that is the reason we use NumPy. If we start doing this in a list, see, this is iteration. It will iterate through all the elements. It's anyways going to be slow. But here, what we are doing, behind the scene, it will use a vectorization. And the addition would be here, and the execution time is slower, as you can see. And hence, we know that NumPy is way faster than Python, as in inbuilt Python function. So you do remember we did a class in the first lecture where we're using core Python tools. So most things that we are doing is doable in Python, but it is going to be harder and the execution also would take a lot of time. Okay. So that's why now we will be using tools like NumPys and Pandas. Okay. If you pay attention, this is how we create an array. Okay. This is how we create a 2D array. Okay. We will be doing while you share your screen and I'll also like help you understand like how to write it. Okay. How do you get the type of an array? This is the type of an array. Now, if you see array of shape, so we created a 2D array. Okay. This as two rows and three columns. In a shape will return a tuple. The tuple will have two values. The first value is going to be rows and the second value is going to be tuple. Oh, sorry, column, my bad, column. Okay. And next, what we are going to see, we are going to see the size. See, it is not only the time complexity is less, the space complexity is also less. If you see the Python list size is this. This is the byte. I mean, I have to calculate 1, 2, 3, 4, 5, 6. Like it's 8 million bytes. Yep, yep, 8 million bytes, approximately 8 billion bytes. But in NumPy, it is 4,000 bytes. Can you see the difference? Like how efficient it is. Okay, and that's the reason we use NumPy. Okay, let's do one thing. I am keeping my screen right here. Maybe you can do a code along, and if you have any doubt, let me know.
Okay.
Okay, the screen will be right here. I'll zoom it for you. Okay, just start with this point.
Sir, sir, hello.
Yes, Devesh.
Sir, there at the end of the two lines, print add range 0 to 10. What is the use of
Mhm.
it?
Oh, yes, definitely. So this is called slicing. So what we are doing, we are taking a range in an array. The first value is 0th element and the last value is 10th element. So 0 to 10 elements. So if you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9 element will be printed. So this
Okay.
is how you slice it.
And sir,
Got it?
the print and hyphen start.
That is and minus start. So this is the start time. At this point, we get the start data. And time, we get the end data. What we are doing, we are doing end minus start. And so that we are getting the time that is taken to execute.
Okay. 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 Okay.
Okay, cool. Devesh, is this done?
Yes, sir.
Oh, you tell me, like I'm waiting on you. There's nobody, so let me know when it's done. Okay, it's done, so I have to like scroll down, right? So were you able to see the difference when you are running it? Okay, so this also you need to check. Maybe let's not, let's go ahead. I mean, the purpose of this notebook is done that I wanted to show that the NumPy is way faster. And here, if you can check, it is also memory efficient. Do you want to get this line of code or we're good? Shall we move ahead?
So we can.
Okay, let's move ahead. Okay, we will go to creating arrays. Okay, how we create an array. Okay, the first one is import NumPy as NP. This is how we import it. The reason being, if you don't do it that way, we to use all the available functions and values, we have to write NumPy dot zeros, NumPy dot one. Because we have done it as NumPy as NP, we would be able to use NP dot zeros. Did you get it?
Yes, sir.
You get it, right? Okay. Now this is how you install any package inside the Jupyter Notebook. That is exclamation mark, not pip install. I call it not. That's logical, it is called not, that's why, but you can call it exclamation mark pip install NumPy. This will install this. But I don't think you installed NumPy on your system. It was already installed, right? Because you have installed Anaconda. So this is not needed in your case. Okay. Now this is how you create a NP array. Okay. Array np.array. The argument it takes, it can be 1D array, 2D, 3D, any D, and it will create an array. Okay. While we're doing it, just maybe you can code along. Okay, create a notebook and create an array. Just the third line. Then we'll move ahead. The third cell, my bad. I'm audible, right? There's no problem with my audio.
Yes, sir. Done.
Done, right? Okay. Were you able to print the array as in the fourth line?
Yes, sir.
Okay. Now we have np.zeros. Okay. This is a function. It takes an argument, which is a tuple, and tuple is the size of the array that you want to do. So what it will do, it will create an array of zeros. Okay. This will be required in data cleaning, data manipulation. Let's say you want to do an operation and you need an array of all zeros. So this is how you create it. np.zeros, 3 or 4. Then it will create 3, 4, 5. Let's see if I want to create a 3D array, then it will create a 3D array. Okay. Get it? You're familiar with array dimensions. That's not
Yes,
an
sir.
issue for you. Okay. Similarly, there's a function called np_ones. See, all these functions you may not remember, but at least you should know that there are such functions which can create one. There are such functions which can create zeros. So all of this would be useful. Similarly, we have np_ones. So it will create, as the name suggests, it will create an array of, of one value. Get it? Same. It will take tuple as an argument, where it could, the first element is the row, second element is the column. We can also create a 3D array, and we have a 3D array. We can also create a 4D array. Okay. Let's say if you want to do it in Python, it is going to take a lot of time. So there are a lot of inbuilt functions which are available in NumPy. Usually, I mean, I have worked on NumPy. There are very rare cases where I have used let's say 4D or 5D array. In most cases, 3D array or 2D arrays has solved my purpose. Okay. Now we have np.full. So np.full will create an array like this, as you can see. First element, the size of the array. This is what we call the size of the array. Okay. 4 of 6. And the second element is the value that we want to full. Get it? Okay. Let's say we want an array of 8. We get an array of 8 of size 4 to 6. If you do it of 9, then this will create an array of 9. Okay. The next one is np.I. This creates an identity matrix. So in an identity matrix, the value of diagonal is 1, whereas rest all the values are 0. This will take only one argument because that is not needed. Let's say so 5. This is how you create an identity matrix. Now identity matrix, if you do this, this will, oh sorry, if you do this will not work because an identity matrix is usually a 1D array. Okay. You can't create it's not like it will create multiple arrays of one. So let's say if you do 4, then this is how it will create. Okay. Even if I try doing it 4, this will run into an error. It only takes integer as an argument. Get it? Okay. Then we have NP of A range. NP of A range is similar to what range is in Python list. We are creating an array from 1 to 100 and the step is 10. So first element is 1, plus 10 is 11, plus 10 is 21, plus 10 is 31, plus 10 is 41, plus 10, 51, 61, 71, 81, 91. Now we do plus 10, it is 101, which is out of range. So it will not push into this array. Did you get it? Get it right?
Yes.
Okay.
Yes.
If I do 0, it will not because it will throw an error. If I do, let's say, 5, this is how it is. Similar to range function in Python list. Get it? Next one is a linear space. Okay. So from 1 to 100 element, and I want the distance between them to be 5. So that is going to be linear space. So all the elements are at equidistance. Okay. 1 to 27.5, then 50.5, 75.25, then 100. So how is this happening? First element is 1. The difference between all the element is equal, if you are saying. Okay. Did you understand?
Yes, sir.
Linear space. Okay. My array. Okay. We are creating an array. This is a 2D array, and this is how you created 2D array. Okay. Yeah, got it. This is how you get a shape of an array. Array.shape. It will return the value, which is a tuple. Then array of size. Okay. Now the dimension of an array. As you can see, this is 2D array. So it is telling you it is a 2D array. How do we get a dimension? By ndim. Okay. Array data type is type. Yeah, one more thing I want to add. So in NumPy, you can put anything inside the array, whereas in list, the type of the element inside the list should be similar. You can't put strings in integers, an array in a Python. So I'll show you. Maybe that I can do. Okay, let's say what I'm doing 1A. Okay, list. Okay, this is how it is. But let's say you can do it 1, 5. Then we have NP is equal to PRR is equal to the dot array list. Okay, typation. No, actually, you can do. I think that's wrong. So that's one of the things when I got to know. You can have multiple data types in a list as well, but you can also have them in NumPy. So there it is. Oh, okay. the type is string for everyone. Yeah, I made a mistake. So in a list, you can have different types of array, but since we will be performing operation in NumPy, the type is sort of change it to a type, dtype. I think what is dtype underscore 32? Let's okay, it's a Unicode. It's a string type. Okay, got it. Okay, so NumPy changes it explicitly so we can perform operation. Get it. Okay. Yeah, you can create any list in Python, but in NumPy, the list type will have to be similar because we'll be performing operations onto them. Okay, so where were we? We were here. Okay, ndim. Okay, d type. If you see the type is integer. Okay, the type is integer. Then we have NumPy array. Now we want to create an array of float. So second argument in NumPy array is what type you want to create. As you can see previously, all of them were integer. You see here, all of them are integer. Now they are converted to float. They are of type float. Get it right? Okay. Okay. My array. Yeah, mm, we create an array. We run it. We do it. Okay. We are initializing the array in n. So if you see, so we are changing the type. Okay. The type was float 32. The type is float 64. Let's check. Float 32. That's it. Float 64. Okay, float 64 will take 64-bit of memory. Float 32 will take 32-bit of memory, which was very self-explanatory. And float 64 is more precise because it can store decimal value up to more numbers. Get it? Okay. Similarly, dtype is a function. It will tell you the type of an array. Okay. The n dtype is float 64, but the array that we created previously it is float 32. Okay, I'm going a bit fast because you will be writing it again while I'll be sharing the screen. Okay.
Okay,
And
sir.
I think we have went too far. So from this cell, we will continue. Oh, it's this much. Let's finish it. Okay. If you have any doubt, we'll go through it. Okay. Again, we are creating an array. This is how you get the shape. Okay. Now you can also reshape the array. Okay. The size of this array is 4, 3. You can make it 3, 4. You're getting it. Okay. This is reshaped array. The reshaped array is like this. Okay, now there are 4 elements and 3 columns. If you see a two array, we reshaped it. Get it? If you want to, let's say, reshape the matrix. Okay. You might have solved a lot of matrix problem in back in college. Was there
Yes, sir.
that you transpose a matrix when you want to calculate, you calculate the row to the first row column of the element, then second element you make a sum. All that you have done, right?
Yes, sir.
Okay. Okay, cool. Then again, these are reshape. The other one is flatten. Flatten is an important function. Maybe you should remember this. So what it will do, let's say no matter what the dimension of the array is, it will flatten it into a single array, a single 1D array. So that's what it does. Okay, and this is our function, which is not very useful. Okay, go ahead and write it down. And if you have any doubt, you wrote it till array. Now you can start with the empty zeros. Okay, go ahead and make few changes so that you understand like what is and make changes in the argument so you even remember it. Okay, let me know when you're done.
Okay. Sir, done.
Done, right? You want me to scroll?
Yes, sir.
Okay. We're able to create the zeros. We're able to create the ones,
I also completed.
the fulls, right?
Full and I also completed.
Okay. Oh, identity matrix. The E-range matrix. Okay. While you're doing it, think like what it is. Similar to the
Yes,
list
sir.
elements.
Sir, what is the role of I? It make a like a diagonal one in our matrix, right? In what?
Yes, yes, yes. The diagonal elements are one. Rest is zero. That is an identity matrix. That's what you call an identity matrix.
Can we pass in multiple multiple parameters in I?
We cannot. What? Let's see. Okay. What we'll do? And see that I will just do it. Every time any doubt, you see. So these are the elements that we can pass. Okay. We can pass integer, M, K, data type, order C, device. You meant tuple, right?
Yes, sir.
No, we can't pass. So identity matrix is a 1D, it's a 2D array with like diagonal. Alright? So it can't be more than that. See, it returns a 2D array with ones in the diagonal and zero elsewhere. Okay. And the first element is integer. Second element is number of columns in the output. If none is, that's it. So what we'll do, we'll use this documentation and check. Okay. Hmm. np.I. Okay. The second is optional. What we will do, number of columns, let's say 10. We'll go by 10. So it is creating an identity matrix with 10 columns. Okay. So the last element is zero. You're getting it? It's an identity
Okay, sir.
matrix, but this whole 10th column is zero. Okay. You can pass 30 columns. If you see, it's not readable, but if you see till 9, it will be identity. After that, all the elements would be zero. Okay.
Okay.
Similarly, we can pass a type float. Let's say if I want to do a type float. See, this dtype float is an argument for every, what do I say? Every NumPy array that you create. Okay, how do you do a dtype? Dtype is equal to, we did a float 64. Okay. Now this is a float 64 type. You see 1 point. Okay, so these are the argument we can pass. If you have any doubt ever, what do? You go through the documentation and understand it. Okay, that's
Okay.
the best way to do it. Okay. Okay, let's continue with the range. Any doubt, let me know. I mean, see, all of the functions and things are self-explanatory, so I don't think they're needed. So let
Okay,
me know
sir.
if there's any doubt.
Sir, done.
All right, I'll scroll it down. Here, type. Let me know when done.
Done, sir.
All right. No doubt anywhere, right? Your NP array
Yes.
data type. This is what we are changing the type. It was float of 32 type. We're changing it to float 64. Okay. Linear array, you understood, right? What exactly is the purpose
So
in
no, sir.
equidistance?
So what is the doing like how the 25.75 50 point?
Yeah, you're supposed to ask that. See, linear space 1 to 100. Maybe I'll create an array right before. So we want to create an array of five elements. It is 0, 1, 2, 3, 4. There are total five elements. And the distance between all the elements should be equal. Linear space should be linear, and the space between them should be equal. So if I
Okay.
do 1 plus 100, the first element is 1. Okay. Let me see if this is a calculation or not.
Divide by 5.
Not okay. There are five elements, right? So if I do five, I don't think that's how it works. So the distance is five. Let's say if you see 25.75 minus 1 is 24.75. Okay. 50.5 minus 25.75. It is
Mm.
24.75. Okay. Then you see 50.5 minus 25.25. It is, I mean, I thought of it. I did a mistake. It should be 75 minus 25. The difference is 24.75. So difference between the next element and the previous element should be equal. Should be equal. And that's how you create it. So if this is how you create an array. It's a linear space. First argument, the range 1 to 5, and the equidistance. I mean, you want five elements, okay? And they all should be equidistant. Get it? 100
Okay.
minus 27.5. What would be the difference? 24.75.
So,
Got it, right?
yes.
Difference between each element is equal. Okay? Okay. Where did you end up? Did you finish the type? Did you do reshape? Reshape is done, right?
Reshape. Yes.
Okay, I'll scroll down and that's it. Once done, let me know.
Done, sir.
Understand? Any doubt anywhere? Any
No,
function, any you did not understand.
no, sir.
Right? Okay. Cool. We'll go ahead, we'll move ahead. We'll understand indexing and slicing using NumPy. Okay. So this time let's code like while I'm explaining. So that would be faster. Okay. So first line we are importing NumPy and then we are creating a 2D array. Let me know when you're done. I'll copy it so that you can do it faster. Okay. It's on the chat.
Done.
Done, right? Okay. Okay. So this is essentially a 2D array. Okay. So when I use flatten, what should be the output? If you can tell me.
So it will be flat like 1 to 3 and 1 to 13 numbers in a single list or single
Single
array.
list, right? Single array. Okay. It will be a 1D array. Let's see if that is correct. See, yeah, it is a 1D array. Okay, 1 to 30. Now, if I want the first element of the array, what I do? See, just like Python, this is how we use it. We want the first element that is, I mean, zeroth element. So that is flat of zero. We got the flatten array. Flat of zero is the first element. Okay. Okay. Let me know when done.
Done, sir.
Done, right? You're familiar with the list function. So in NumPy, the list functions and the parameters that I use, it is similar to lists in Python, the Python inbuilt function. So as you can see, flat 3 of 6 should return 4, 5, 6. That is third element, 0, 1, 2, 3, third element, fourth element, 5 element, fifth element. This is how
Yes,
you
sir.
slice an array. Okay. Now this is, as you can see, flat. If you don't pass
0,
0,
0 to
it
4.
it will, yeah. If you don't pass an argument, it will take the initial, that is 0th 0 as the default argument. And similarly, if you don't pass the second argument after the colon, it will take the last element as your
N minus 1.
end. So let's say if you, this is zero, this is this thing last element. If you pass the first element, it will take the last as an argument. If you pass the last second value after the colon, it will take the first as an argument. Okay, got it? Okay. Similarly, what we'll do 3 to 13, and we have flat. Okay. What we'll do, I think if you can write it down and let me know when you're finished. This is slicing. This is how you slice it. No need to write all of them. Maybe one or two would be enough.
Done, sir.
Done, right? Okay. Now let's understand the copy function. The copy function is one of the important function to understand. The reason being, uh, let's say if you are in NumPy, it usually, let's say if you assign a value, it is assigned by reference. So if you don't do a copy, if you change the value, the real value also will change. So in that case, copy helps us to create a copy of it. So it will be completely new array. It won't be referred to the previous array. So let's check here. What we'll do, we'll create np dot sorry np dot array. It will be 1, 2, 3. Okay, created an array.
So I think
Okay.
it was a concept like shallow copy and deep copy, right?
Yes, exactly. So if I do b equal to a, okay, and if I print b, it is 1, 2, 3. Now what I'll do b of 2 is equal to, hmm, can we do this? B of 2 is equal to 4. Okay. Now we do a B, 1, 2, 3, 4. Now similarly, if you do an A, this also change. Okay. Now if I only want B's value to change, what I have to do? I have to do A dot copy. Okay. NP of array, this is A. Now if I'm doing a copy, I'm changing the second element. Okay. If I'm printing the B, it will be 1, 2, 3, 4. But if I'm doing A, it is 1, 2, 3. Because now I've copied. There is no reference to A. It is a completely new array to B. Okay. So that is the concept of copying. So I'll delete it. It's not needed anymore. And this and this. Similarly, if you create a copy, this will create a copy of an array from 3 to 7 element 4, 5, 6. Okay. This is how they're assigning the value. If you're printing it, this is the value. B of 0 has changed. So it is the third element is again is now the first element of the array. Because what we are not creating a slice, we are creating a copy. There is no reference, it's a new array altogether. Again, it's a flat, and if you see flat, the value of flat did not change. Got it? Okay. Okay. Once you are done till this, let me know.
Done, sir.
Done, right? Okay. Now, next, what we are going to see, it is very useful. Okay. This is conditional iteration. So, what let's say if you have an array, we create an array. Okay. Then we have array of 146. So, what it will do? Oh, sorry, I have to define the array. Yeah. Okay. This is an array. It is a 1D array. Now, I only want the first element, fourth element, and sixth element. Okay. So, what I'll do, this is how I can get it. So if in an array, this is not something you can do in Python. It's a very NumPy specific. If you pass another as an argument, so this array would be the indexes of all the array, and it will return 54, 2, and 34, as you can see. Array of 1 is 54, array of 4 is 2, array of 6 is 34. And that is how it is returning. Get it? And the next one is array of 23. So what we are doing, we want array where the value of array is greater than 23. So it should be 54 and 34. We can also do conditional, this thing. So okay, sorry. It went to, so this is only showing the value because it will not change essentially unless I assign directly to array. So in this array, the value would be 54, 53, and 34. The values which are greater than 23. Okay, 54 is greater than 23, 50, and 34. These three are greater than, so it will return here. Okay, always remember, NumPy does not explicitly change the array. It will return the value. If you want to change it, so this is how you do it. You do it array is equal to array of 23. Once you assign it to itself, then it will change. Okay? Okay. Once you are done with this, let me know. We'll do an exercise. Done, right? Anything you don't understand, please ask. Got it? Okay. Shall we move ahead to exercise? Okay, this is the exercise. Can you see my screen? Okay.
Yes, sir.
Okay. Create a 3D array filled with random numbers. Okay, and print its shape. You can Google it, like how to create a NumPy with random numbers. NumPy with random.
So I think you can buy the red and
Sorry, by what?
there is a function in red and I'm trying.
Yeah, yeah, try it. And maybe if you can, yeah, once you're done, let me know. So in software development, more important skill is Googling. And now ChatGPT and cloud has come into picture. So asking right question is more important.
Oh, so done.
Done, right? Okay. If you can, okay. Done with all of them?
No, no. First question.
Okay, cool. Were you able to print a floats or was it like 0 point number? Like, was it integer?
No, no. It these are the float numbers.
Float number? Okay. Okay, cool. Convert an array of floats. This is the array into integer. Okay, you have to change the d type.
Sir, I have used the use second question like arr dot dtype equal to int32.
Mhm.
Then print the array, but it is generating like minus numbers.
Okay, I think do it in int 64. Share your screen. Let's solve it together.
So it is visible.
Yeah, you created a random array. Okay, array of d type is equal to int 32, and this is how the problem is. Mm, no, so this is not what you use. You use as type. That's what you use. Now print the array. Objective is um, okay. It's a this thing. It's a function. So the argument that goes, it's int 32. Okay. Now if you run the array, okay, how come the value is negative? It's float 64. Okay, do an int 64 because maybe this value has changed and that's why there is bit manipulation at a level. Okay, run the array again. Line number three, run all of them. No, column number three, I'm saying. Column number three. You don't have to print it again. It will anyways show you. See, go to line number two and run it.
So which line?
Cell
Which
number two,
line?
cell number two, cell number two. Okay, run it. It will create an array. Again, run the second element. And do a run on 0.7. Now run 10, the next cell. See, integer type is 0, so it is working.
So how is it happen?
Your float type was 64. You tried to convert it into int 32. So then there bit manipulations happen. Okay, there were
So but
64 bit. Now there, yes.
so but we have the लाइक हमने पहले ही कर लिया था तो फिर नीचे आके क्यों किया था मतलब कि हम तो नीचे आके कर रहे हैं ना उससे 64 उससे कैसे पता चला कि हम ऊपर
नहीं, वो डिफॉल्ट फ्लोट 64 है. जो
ओ,
डिफॉल्ट रैंड टाइप आया वो फ्लोट 64 है. अगर आप वहां पे डी टाइप इज इक्वल टू 32 करके करोगे तो इन 32 चल जाएगा. वहां पे करो एक
ओ,
बार कॉमा डाल के डी टाइप इक्वल टू 32. आई थिंक रैंड में शायद नहीं होगा, देखना पड़ेगा. हाँ, नहीं जाता रैंड में, रैंडम में नहीं जाता. हाँ, वो बाय डिफॉल्ट फ्लोट 64 देता है. ठीक है. डिड यू गेट इट लाइक व्हाई दिस इज अ प्रॉब्लम?
so no, like how is it happening, like earlier we same code we are running.
नो, I'll explain you. So the default d type is 64. Okay, and in rand the default d type is 64. You try to convert it into a 32 bit. Then the
Okay,
bit manipulation happens. So in this bit, the bit gets you understand bit manipulation. Did you check it? Like, let's say if you want to do a summation of 0 and 0. I actually don't remember it. I did it in college. It's been 10 years. So you run it. If the value is more than 2, you do a carry over 1 and all that. Do you
yes,
remember
yes, I
that?
have done. Yes,
Yes, exactly same thing happened. There was 64 bit. Now the value got compacted into 34 bit. उसको आधी जगह मिली. तो value change हो गई. Calculate करेंगे, we will know what exactly is the change, but right now I don't know how to calculate it. So that's
okay,
how it happened. Got it? Okay.
yes sir.
Now, again, create an array 1, 2, 3, 4, 5, 6. No, no, sorry, NumPy array. When I say array, it's NumPy array, my bad. Okay. Now, using fancy indexing, if you remember, we passed an array inside of an array and it returned all the index. Okay. Just get the even numbers. You use fancy indexing, but it's not even number. So 0, 1, 2. This is third element. So it will be 2
Oh,
will be first element. Okay. Now create a random integer with type int. So for that, what you have to do? np.random.randint of 3
Sorry,
cross 3
sir.
matrix.
What I have to
Create a
do?
random integer of type int.
So simply we I have to pass the number like int.
No, no, no. Do an np.random.randint.
So is it
Yeah,
correct?
yeah, it's correct. Yeah, 3 cross 3 matrix. Okay, print it. Oh, what's the okay? There's a low and high. Okay, let's solve it together. Okay. What is the problem? The low should be greater than high. Okay. The range of index. Okay. See what is the problem here. Go to the documentation and check what is the problem. No, you're not sharing your entire screen. I won't be able to see it if you can share it again. Remember, we got a value error which is low is greater than high. So that means it takes two arguments. One is low and another is high. And because 3 is not something that is satisfying its condition, and that's why the error. Okay. Try searching for how to create rand int. In our case, we already know. So just search np.random.randint and you'll get it. Random.randint. There's a hyphen sign at the beginning, but I think Google will understand. That's fine. You got the right result. Okay. Better way is to go to documentation directly, which is just scroll down. Yeah, take me there. See, first is low, second is high, and is integer. So it's a returns random integers from low to high. Get it? So it does not create an array. It will return an integer. So if you want an integer between 1 and 2, then this is how it will create it. Okay, that's fine. That's fine. What we'll do, you already have an array. Okay, just multiply it by 10 and then convert into int 32. The above array that you have. Now, screen, can you zoom your screen a bit?
Now it
Yeah,
is
full
visible,
screen.
sir.
Yeah, it is visible. You already have a random integer. Okay, you do multiply by a 10. If you go to an array, show me the output of your random integer. Now we have array, right? So array is 0.7. What you do? You do array equal to array into 10. Into 10. I think that should do it. Yeah, run it. Okay. Now convert it into 64. Int 64. Run it. See. Now we have an array. Okay. It's supposed to be 3 cross 3 matrix. Okay. The second argument should be tuple. I wanted to create a not here, like the second cell.
Yeah, right.
No, no, second cell. See, the rand 3 of 3. That's not how you do it. The second argument is a tuple. So you pass it as a tuple. So it will create a 3 cross 3 random matrix.
So how like 3 cos 3 under the tuple, right?
Inside the tuple, it will create a 3 cross 3 matrix. Hmm. Oh, no, no, no. That's not how you do it. Okay, my bad. Let's go ahead and check again. Every time we make a mistake, we go to documentation. Search for it. Randoms.rand. Rand. You there, Devesh? I think I lost. Yes. Can you hear me?
Yes.
How did you get removed?
So I don't know like what happened in my laptop. It randomly switched the like Chrome and other.
Okay, okay, not a problem. Not a problem. Okay. Share your screen again. So it does not take tuple as an argument. It takes the size as an argument.
So is it
See,
visible?
yeah, it is visible. If you see that R and D rand, whatever dimension you want to give, you can give. So you don't have to pass tuple necessarily. Okay. So we wanted a 3 cross 3 matrix. Go to your screen where we were solving it. Yeah. Okay. Now run it. It should be 3 cross 3 matrix, right? Sorry, it's a 2D array. No, 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 no. Print the array. Print the array first. I want to see it. Okay. It's a 3 cross 3 2D matrix. Okay. Yeah. If you click on the plus sign, it will create an array. Okay. Now but whenever we are changing the type, it is becoming a 1D array. Click on it. No. Okay. No, you want to array into. Okay. Now print the array. Ah. Okay. What was and now if you change the type, so there is
So it's
some
giving in
problem.
float.
Why is it float? There is something. Okay, D type is N64 is 0, then you okay, see, execute the first line, okay, then delete the next line. Just don't change the type right here. Okay. Multiply it by 10 and print the array. Okay, this is 7 point whatever. Now if I convert into integer, it should be 8, 4, 2, 9, right? Now convert this into an integer. Set the yeah. See, this is what I wanted. Okay. And if you print array, did it change? Yeah, it should change. It's a function. Now print the array. So last time this did not happen. I think we made a mistake somewhere. That's what I wanted to check. And see, array is equal to array.astyle. That's what you do. You assign it to an array. At the cell 36, if you're seeing, we are just so the array does not manipulate itself. What you have to do, you have to assign it to an array. So it has to be array equal to array.astype int of 64. That's how it will change. Yes. Now run it and now print the array. Now there's one homework for you. You go ahead and search the shortcuts for Jupyter Notebook. You know how to run it. Shift enter is one of the shortcut. Control enter is one of the shortcut to execute. So all of this once when you I mean before the next class, just take a look at it. Okay, let's
Okay.
come here. Let's go to the exercise problems. Okay, now reshape this matrix into 1D array. There are two ways to do it. Okay, let's do it. Reshape it to a 1D array.
Okay.
Flatten it is not flatter. N at the end. Okay. Okay. I have to print flat as well. You see, it's a 1D array. Now there's another way. Use reshape function and do it. It's a 3 cross 3 matrix. I only want a 1D array. So how would you do it?
So how it will.
There are 9 elements. Do a 9 comma 1. Will that work? Run it.
So 1,9.
Okay. Do a 1 comma 9. It should be 1 comma 9, right? So 1.99, right? Yeah. It's flattened. 1 comma 9 should be. That should be 1 row, 9 columns. Okay. Always remember. First one is row, second one is column. Okay. Now, okay, we have a array, right? Now filter the array where the elements are greater than 3. How would you do it? So no need to assign it every time because you have to again print it. See, all the elements which are greater than 3 are visible. Okay, excellent. We have finished the exercise. Okay, it's 10 already. Do you want to continue or do you want to continue in the next lecture? Devish, it's 10 already. Do you want to continue
Yes, sir.
further? Cool.
So
Okay,
we
we'll go
can
ahead.
now end up.
Oh, you want? Okay, okay. Okay, cool. Okay, I'll end the class right here. So one thing I want to check, I think there's some problem with the technique. I'm planning a lot of things, but I'm not able to do it. So maybe I'll plan it better next time. I wanted to finish at least NumPy today and get started with pandas, but that's not done. And also, a lot of people has not joined, so that's fine. And let me go and check what else is remaining. Mhm. Okay, we did indexing and slicing. We still have a few things on this thing, NumPy. Okay, so there are homeworks for you. First is understand NumPy, like play around, watch videos, how NumPys work and all that. Maybe take a large data set and manipulate it. You'll like it if something that has a million rows and columns. So you'll be able to understand, run filters and run all the commands that we learned today. And the next one is learn Jupyter Notebook, the shortcuts and everything, how to create new cell and all that. What are the shortcuts? Space bar, markdown, everything. Okay, that is homework for you. And in the next lecture, we will finish NumPy, which I wanted to do it today, but that's fine. We will finish it in the next lecture. Okay, see you next week. I hope you enjoyed the class. Let me know if there's any feedback and see you next week. Okay, bye. See you.